Hello guys, welcome to XMS tutorials. In this video we are doing a question paper which is a past exam paper written in November 2020, paper 1, which is from the Department of Basic Education, which is a South African examination board. This paper is marked 3 hours long, so I want us to go step by step and see how we answer the questions up to the end. So if you are a grade 12 learner who is preparing to write an exam, you can watch the video up to the end. In mathematics, what matters is the speed and accuracy, meaning you must have speed when you answer these questions as well as maintaining the accuracy. In this paper, you answer all questions from question 1 up to the end. Question 1 reads, solve for x. The whole of question 1 is the algebra. So it is asking us to solve for x, which is 1.1.1, 1.1.2 up to 1.1.4. So let's start. The question is x squared minus 6x is equal to 0. To solve this type of equation, this is a quadratic equation that we need to factorize first. So a common factor is x. Then inside the bracket we'll be left with x minus 6. Then you let x is equal to 0, or x minus 6 is equal to 0. Therefore our x is 0, or this one we take minus 6 to the right, that is going to be positive 6. Next question, 1.1.2. X squared plus 10x plus 8 is equal to 0. Correct to 2 decimal places. Once you see a question saying correct to 2 decimal places, don't bother yourself trying to find the factors. That question will not have factors. So what you can do, go straight to the quadratic formula. The quadratic formula, which is x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. Our a is the coefficient of x squared. In this case, our a is 1. B is the coefficient of x, which is 10. Then c is the constant value, which is 8. So now we substitute that into our formula. So our b, which is 10, so that's going to be minus 10 plus or minus square root of 10 squared minus 4a. Our a, which is a 1, then our c is 8, all over 2 multiplied by our a, which is 1. This step is very important. The examiner wants to see the correct substitution of the values. So don't do the shortcuts, skipping this step. First thing, you write your formula, then you show the correct substitution of values here. Then after that, you can go straight to your answers, or you can simplify the value under the square root. That is going to be minus 10 plus or minus root 10 squared minus 4 multiplied by 1 multiplied by 8. This is going to give us 68, all over 2 times 1, which is a 2. Then the first solution is minus 10 plus square root 68 divided by 2. This is going to give us minus 0.8768, but the question says round off to 2 decimal places. That is going to be minus 0.88. Or with negative sign, we are going to get minus 9.123. To 2 decimal places, that is going to be minus 9.12. So this is our solution for 1.1.2. Next one, 1.1.3, that's a quadratic inequality, which is 1 minus x multiplied by x plus 2 is less than a 0. So what we need to do here is to find the critical values. Critical values is you solve for x here. That is going to be 1 minus x is equal to 0, or x plus 2 is equal to 0. So this will give us x is equal to 1, or x is equal to minus 2. These are our critical value. So I'm going to use the graphical method to solve this inequality. So this is going to look like this. X is equal to 1, it's here, x minus 2. And after having our critical values, you need to check the shape of your graph. Remember, this is a quadratic graph, which is in the form ax squared plus bx plus c. So we are going to expand this one. This is going to be 1 times 1, we get x. 1 times 2, that's a 2, minus x times x, we get minus x squared. Then minus x times 2, that is going to be minus 2x. It's less than a 0, like that. Then we have our x squared is going to be minus x squared. Then x minus 2x, that is going to be minus x, then plus 2 is less than 0. So the coefficient of x squared, that's our a, is negative. So our graph is n-shaped like this. So this will look like this. Then the question is saying it's less than 0. Our 0 line is this x-axis. So if it's less than 0, we are going to shade this region. That's where we have our solution. So our solution is from x is equal to 1 going to the right, and x is equal to -2 going to the left. So our solution is going to be x is less than, this is for this side, so it's going to be less than -2, because on the left is a less than side, or x is greater than, this is a greater than side, 1, like this. So that's our solution for 1.1.3. X is less than -2, or x is greater than 1. But some, they will choose to use the other notation of representing this. The other notation is for the infinite signs. Like here, we are from 1 up to positive infinity. Here we are from negative infinity up to -2. So when you give your answer, you say x is an element of, we are from negative infinity up to -2, or x is an element of, we are from 1 up to positive infinity. Let's go to 1.1.4. Square root of x plus 18 is equal to x minus 1. So this type of equations, you need to clear out everything on the side of the square root first. But this one is okay, we only have square root of x plus 18, so that's okay like that. But let's assume that there was a plus 2 like this, which is outside the square root. We have to take it to the right first. So now we must get rid of the square root. We need to remove it. So the only way to remove a square root is by squaring both sides. What you do on the left, you do on the right. So this side, the square root will go. We'll be left with x plus 18. Then we need to expand this one. You can do the direct expansion of these two brackets. This is going to be x squared. You square the first term, then the middle term, you say x times -2, we get -2x, then times these two, that will be minus 4x. Then -2 squared, we get a plus 4. You can use the FOIL method if this one is difficult for you, or you can just use the FOIL method to confirm, where you say x minus 2, like this, then you expand. I just use the short way. So now we take everything to the right. That is, we'll be left with a 0 here. We have x squared. Minus 4x minus x, we get minus 5x. Then 4 minus 18, that is going to be minus 14. So we have x squared minus 5x minus 14 is equal to 0, like that. Then we can find factors of minus 14. That gives us minus 5x when we add them. So I'm going to do direct factorization again. Factors of minus 14. We have minus 7 times 2, or minus 2 times 7. Sure, those are the factors that are very close to minus 5. 14 and 1 is very far from minus 5. I don't think it can give us an answer that is minus 5 when we add. Okay, but if we say minus 5, if we say minus 7 plus 2, that is going to give us minus 5. So these are the correct factors. So we have minus 7 and plus 2. So x is equal to 7, or x is equal to minus 2. But on these answers, we need to check which answer is the correct one, because one of the answer will be not true. So we prove using our original equation. So what we do, we are going to have our square root, then we substitute with the values of x into the equation. So the first one is going to be 7 plus 18, then 7 minus 2. 7 plus 18 is going to give us 25, square root of 25, which is 5. Then 7 minus 2, which is 5. So 5 is equal to 5. So this one is proving that the answer is correct. So 7 is correct. Let's check minus 2. That is going to be minus 2 plus 18. Minus 2 minus 2. Minus 18 plus 2, we get 16. Square root of 16, which is a 4. Then this side we get minus 4. Minus 4 is not equal to minus 4. So our correct answer is this one. Then what we have to do, you say x is not equal to, you need to add this. Don't leave it with an equal sign. It would be telling us that the answer is equal to minus 2. Yet it's not. So you need to put a not equal to, like that. So our solution is x is equal to 7. X is not equal to minus 2. That's where you can end. This one, the proving part, you can do it on your rough paper. 1.2. simultaneous equation. Solve simultaneously for x and y. X plus y is equal to 3 and 2x squared plus 4xy minus y is equal to 15. So when you're answering simultaneous equations in grade 12, we are going to use the substitution method. There is no elimination in this case. So what you need to do here, you use the linear equation, which is this one. You make one of the two the subject, or you can use even this one, but it is easier to use the linear equation. So x plus y is equal to 3. Then you make one of the variable the subject. I can make y the subject. This is going to be 3 minus x. Then we substitute this one into equation 2, which is this one. So that is going to be 2x squared plus 4x, our y, which is 3 minus x, minus y, which is 3 minus x, then is equal to 15. This is going to be 2x squared plus 4x times 3, that is going to give us 12x. 4x times minus x, which is minus 4x squared, then minus 3 plus x is equal to 15. Then terms in the same degree, they'll add each other, which are like terms. 2x squared minus 4x squared, which is going to give us minus 2x squared. 12x plus x, which is 13x. Then minus 3, we take 15 to the left, that's going to be minus 3 minus 15, which is going to be minus 18, is equal to 0, like this. We can use the quadratic formula because what I'm seeing here is like it will be difficult for us to factorize. So we can use the quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac, then all over 2a. Our b is 13, so that's going to be minus 13 plus or minus b squared, which is 13 squared minus 4ac. Our a, which is minus 2, then our c, which is minus 18, divided by 2 multiplied by our a, which is minus 2. So let us see our solutions here. The first value of x is 9 over 2 or 2. Now we are going to the y values. So I'm going to erase this part. For the y values, now we substitute the x values. We can use this one. So y is equal to 3 minus the first x value, which is 9 over 2. 3 minus 9 over 2 will give us minus 3 over 2. Then the other one is when x is equal to 2. So that is going to be y is equal to 3 minus 2. This will give us a 1. So our solutions is x is equal to 9 over 2 or 2, and y is equal to minus 3 over 2 and 1. So the simultaneous equations in grade 12, usually they have 4 solutions, 2 for x values and 2 for y values. Let's go to the next question, 1.3. If n is the largest integer for which n raised to the exponent 200 is less than 5 raised to the exponent 300, determine the value of n. Here you need to pay attention on largest integer. What is an integer? That's what we need to know. These are positive and negative whole numbers. So our answer should be a whole number. So our n raised to the power 200 is less than 5 power 300. We need to find the value of n first. To solve for n here, we can break these 200 into n squared, or raise to the power 100, less than 300, that will be 5 cubed, or raise to the power 100, like this. Then 100 and 100 can cancel out, then we'll be left with n squared is less than 5 power 3, like this. Then n squared we can multiply by a reciprocal half, so that it can go then times half, like this. This is going to give us n is less than 5 power 3 over 2. 5 power 3 over 2, which is equivalent to 11,18. So our largest integer is going to be equal to n is equal to 11, because we are told that n is less than 11,18. So meaning the largest integer will be below 11,18, which is 11. So that's our final answer. Let's go to question 2. 2.1. It reads 7xy minus 11 is an arithmetic sequence. Determine the values of x and y. So what we can do here, we find the difference between these first two terms which is t2 minus t1, that is going to be x minus 7. Then this one, that is going to be y minus x, and this one, that's going to be minus 11 and minus y. So we want to form a pair of simultaneous equations. The first one is x minus 7 is equal to y minus x, the first two, because we know that in arithmetic sequence you have a constant difference. Then we collect the like terms. This is going to be x plus x. We get 2x minus 7 is equal to y, like this. This is our equation 1. Then equation 2, we can do this. Y minus x is equal to minus 11 minus y. This is going to give us 2y minus x is equal to be minus 11, like this. Then we are going to substitute with equation 1 into equation 2. So our y is equal to that one. So that's going to be 2 multiplied by 2x minus 7, then minus x is equal to minus 11, like that. This is going to give us 4x minus 14 minus x is equal to minus 11. This is going to give us 3x. This is 4x minus x. Then minus 11 plus 14 give us 3. So our x is going to be equal to 1. Then the y, we can use this equation. Y is equal to 2x, our x which is 1 minus 7. So y will be equal to 2 minus 7, which is minus 5. So our solution is x1 and y minus 5. 2.2. Given the quadratic number pattern minus 3, 6, 27 and 60, determine the general term of the pattern Tn in the form of Tn is equal to an squared plus bn plus c. So our pattern, the first term is minus 3, 6, 27, 60, going up like that. So the first thing we can do is to check the difference, which is the first difference, 6 minus minus 3, which is 9, 27 minus 6, that is going to be 21 and 33, like that. Then second difference, that's 21 minus 9, which is going to be equal to 12. Then 33 minus 21, which is equal to 12 again. So this is a quadratic number pattern, which is well known for its constant second difference, which is 12. So that's 12 is equal to 2a. Then 9 is equivalent to 3a plus b. 3 is equivalent to a plus b plus c. So what we are looking for is the value of a, b, and c. A, b, and c. So for a, we can use 2a is equal to 12. Then we divide by 2 both sides. A is equal to 6. Then 3a plus b is equal to 9. Now we're looking for b. Substitute with the value of a, which is equal to 6. So that's 3 multiplied by 6 plus b is equal to 9. So b is equal to 9. That is going to be 9 minus 18. We get minus 9. And now we're looking for the value of c. A plus b plus c is going to be equal to minus 3. Our a, which is 6, b minus 9. Then plus c is equal to minus 3. 6 plus or minus 9, that is going to be minus 3. Then we take it to the right, minus 3 plus 3, that is going to be a 0. So c is 0. Therefore, our general term Tn is going to be equal to an squared. Our a, which is going to be 6, n squared minus 9n plus a 0. There's no need for writing a 0 in grade. Let's go to the next question. 2.2.2. Calculate the value of the 50th term of the pattern. So to determine the value of the 50th term of the pattern, we're going to use our general term Tn, which is going to be equal to 6n squared minus 9n. We are looking for T50. This is going to be 6 multiplied by 50 squared minus 9 multiplied by 50. Then we punch this one in our calculator. That is going to give us 14,550. That's the value of T50. Let's go to the next question, 2.2.3. Show that the sum of the first differences of the pattern can be given by Sn is equal to 6n squared plus 3n. So on our sequence, we have realized that, let me just redo it here. Minus 3, 6, 27, and 60. This was 9, 21, 33. Then 12 and 12 again. So we want to show that the sum of the first differences is this sequence. So the first difference is, if you check, they have a constant difference. So they are going to form an arithmetic sequence. So in other words, the question is asking us to calculate or to determine the sum of terms in these first differences in terms of n, because we don't know how many are they. So we're going to say Sn, which is the sum of terms. We're going to do sum of terms in an arithmetic sequence, n over 2, which is going to be 2a plus n minus 1, multiplied by the difference d. This is going to be n over 2 multiplied by a, our a, which is the first term of these first differences, which is a 9, plus n minus 1 multiplied by a difference, our difference, which is 12. Then this is going to be n over 2. Let's open bracket, 2 times 9, which is 18, plus 12 times n, which is 12n. 12 times minus 1, which is minus 12. Then this is going to be n over 2. 18 minus 12, which is going to be 6, plus 12n. Then we distribute n over 2 inside the bracket. This is going to be n over 2 times 6, we get 3n. Then plus n over 2 times 12n. 12 over 2 is going to give us 6. Then n times n, which is n squared. Therefore, our Sn is going to be equal to 6n squared plus 3n. We have shown it. 2.2.4. How many consecutive first differences were added to the first term of the quadratic number pattern to obtain the term in the quadratic number pattern that has the value of 21,060? So meaning, on our first term, we must add a certain number to get 21,060. So this amount of number that we are adding is what we need to know, which is part of the second difference, because our second difference here, it's 9, 21 and 33. So want to see how much are we going to add from the second differences that are forming a linear pattern from 9 up to infinity. We don't know where it will end, for us to get the sum of 21,060. So in this case, to calculate this number of terms, the best way we can do is to get this value of x first. Remember, there are many ways of doing this question, so if you have your own way, that's okay. What matters is getting to the right answer. We can say minus 3 plus x must give us 21,060. So let's see the value of x. It should be 21,063. So we want to see how many terms are going to give us 21,063. So now we're going to use, since we know that the second differences are making an arithmetic sequence, so that's going to be Sn is going to be equal to n over 2, open bracket, 2a plus n minus 1 multiplied by the difference d. So in this case, our sum is 21,063. Then this expression, we've already calculated it here. So this is going to be equal to 6n squared plus 3n. So let me take this one to the right. That's going to be 6n squared plus 3n minus 21,063 is equal to 0. By solving this equation, I'm going to get n is equal to 59. The other one is giving me a negative value, so you only take the one that is positive. So this is the answer, the value of n. So we need 59 terms to get the sum of 21,060. Those terms are the first differences of this quadratic sequence. Question 3. Prove that the sum of 4 multiplied by 3 or raised to the power 2 minus k from k is equal to 1 up to infinity is a convergent series. Show all your calculations. So in this case, we need to prove that this one is a convergent series. So the first thing we can do is to determine the first 3 terms of our sequence, t1, t2, and t3, so that we'll be able to get our ratio R. So in this case, we are going to substitute for t1. We substitute with k is equal to 1. That is going to be 4 times 3 raised to the power 2 minus a 1. That is going to be 2 minus 1. It's a 1. So that's going to be 4 times 3, which is 12. Then the next one is going to be substitute with a 2. 2 minus 2, which is a 0. 4 times 3 power 0, which is a 1. So we're going to have a 4. Then the next one is going to be minus 3. That is going to be 2 minus 3 is minus 1. That will be equivalent to 4 over 3. That's our third term. So our ratio is going to be equal to T2 divided by T1. That is going to be 4 divided by 12. This is going to give us 1/3. And 1/3 is between minus 1 and 1. Remember, for a geometric sequence to be convergent, the ratio must be between minus 1 and 1. So minus 1 is less than 1/3, which is less than 1, like this. Therefore, the sequence is convergent. Why? Because minus 1 is less than r, which is less than a 1, like that. So this is how you can prove it. Next one, 3.2. If sum of terms from k is equal to p up to infinity is equal to 2 over 9, determine the value of p. So here we can use the formula for sum to infinity. Sum to infinity is equal to a over 1 minus r. Sum to infinity is given to be 2 over 9. So 2 over 9 will be equal to a. A is the first term of the sequence. So the first term is when you substitute with k is equal to p. So that will be 4 multiplied by 3 power 2 minus p, like that. That's our first term. So 4 times 3, 2 minus p, all over 1 minus r. Our ratio is 1/3, because you can see this is the same sequence where we got 1/3 as our ratio. So we are going to substitute with 1/3. This is going to be 2 over 9 is equal to 4 multiplied by 3 power 2 minus p over 2/3. So we are going to multiply by 2/3 both sides. So because our main aim is to solve for p. So this is going to be multiplied by 2/3, then multiplied by 2/3. Then 2/3 and 2/3 cancels like this. Then you are going to have 4 multiplied by 3 power 2 minus p. Then by solving this one, we're going to get 4 over 27, like this. Then we are going to divide by 4 both sides. If you divide by 4, this side is similar to multiplied by 1 over 4. Then it cancels. Then 3 power 2 minus p. I just want to write this one on my left hand side where I have my variable that I'm solving. 4 and 4 cancels. We are left with 1 over 27. That will be 1 over 3 cubed, because 27 is 3 cubed. So this is going to be 3 power 2 minus p is going to be equal to 3 power negative 3. You take this one up, that is going to be minus 3. Now bases are the same. So 2 minus p is going to be equal to minus 3. So minus p is going to be equal to minus 3 minus 2. We are going to get minus 5. Therefore, p is going to be equal to 5. That's our solution for the value of p. Question 4. Given that h of x is equal to minus 3 over x minus 1 plus 2. So if you check, you can see that the function is in the form h of x is going to be equal to a over x minus p plus q. This is a hyperbolic function. So the first question, 4.1.1, is asking us to write down the equations of asymptote of h. Equations of asymptotes, we only have x and y asymptotes in this case. For the x asymptote, you look at the value of p, which is this one, x minus 1. So our minus 1 is the value of p. But if p is minus like this, on your asymptote, you make it a positive. So that's going to be x is equal to 1. Then the y is not affected by the sign. It will remain 2, like that. So these are our equations of asymptotes, x asymptote and y asymptote. 4.1.2, determine the equations of axis of symmetry of h that have a negative gradient. Equations of axis of symmetry, they are in two forms, the one with positive gradient and the one with negative gradient. So here the question have asked us the one with negative, and our gradients can be either positive 1 or minus 1. So for negative, it's minus 1. So this is going to be minus x plus the c. Remember, the equation of axis of symmetry is a straight line. So it's in the form y is equal to mx plus c. Our mx is this part, where m is minus 1, then c. So now we want to find the value of c. That's what we need to do. To find the value of c, we use the point of intersection of the asymptote lines, which is x1 and y2. I'm going to make it in coordinates form like that. Our y is 2, our x is 1, then plus c. So c, we're going to take this minus 1 to the left. That's going to be 2 plus 1, which is a 3. So our y is going to be equal to minus x plus 3. So this is our equation of x is of symmetry of h with a negative gradient. Next question, 4.1.3. Sketch the graph of h showing the asymptotes and the intercepts with the axes. So to sketch a hyperbolic graph, you need the asymptotes, which is the x and y asymptotes. Then you require the x and y intercepts. That's all. So in this case, we only have the asymptotes. So now we need to find the intercepts, x-intercept and y-intercept. Let's get our y-intercept first. Y-intercept, we let x is equal to 0. So this is going to be y is going to be equal to minus 3 over 0 minus 1 plus 2. This is going to give us 3 plus 2, which is a 5. Then x-intercept, we let y is equal to 0. This is going to be 0 is going to be equal to minus 3 over x minus 1. Then plus a 2. We can take this whole fraction to the left. Then we're going to be positive 3 over x minus 1 is going to be equal to 2. Let me take it further here. Then we can multiply by the denominator x minus 1 both sides. We'll get 3 is going to be equal to 2 x minus 1 like this. Then this is going to be 3, 2 times x, which is 2x minus 2. Then 5, then 2 to the left, that's going to be 3 plus 2, which is a 5. Then 2x. So our x is going to be 5 over 2, which is as a decimal is 2,5. So now we have our x and y intercepts. So now we can sketch our graph. I'm going to draw our Cartesian plane. We have our x-axis and our y-axis. Then the first thing we can do is to mark our asymptote lines, x and y asymptote. Our x is equal to 1, so we draw it in dotted lines like this. We label it x is equal to 1 like that. Then our y asymptote is y is equal to 2, which is here. Then we can mark it y is equal to 2 like that. Then x-intercept and y-intercept. Our y-intercept is 5. I'm going to mark it there. Then our x-intercept is 2.5, which is somewhere here. So our graph will be drawn in between the asymptotes. So it's between this y and x asymptote. So it will be like this. Then this side is also between the asymptote lines, but passing through the intercepts like that. So your marks are from the asymptotes, then your intercepts, as well as the shape of the graph, the hyperbolic shape. 4.2, the graphs of f of x is equal to half x plus 5 squared minus 8 and g of x is equal to half x plus 9 over 2 are sketched below. A is the turning point. The axis of symmetry of f intersects the x-axis at E and the line G at D, MN. Then C is the y-intercept of f and G. First question reads, write down the coordinates of A. But before you go to the question, you also study your diagram and check what is happening. Which one is F and which one is G? F is this parabola, then G is a straight line. Where is our origin? Our origin is here. This is also very important to check where your origin lies. So meaning our graph is being shifted to the left. So let's see the questions now. Write down the coordinates of A. A, which is the turning point of the graph. So to determine the turning point of this graph, you come here. If it's given in the form f of x is equal to ax minus p squared plus q. This is the form we are given. P and Q are the ones that are used to determine the turning point. So if P is positive on your turning point, you write it, it's going to be negative. So this is going to be negative 5. Then this one, it will remain unaffected. The sign stays the same. So our turning point is minus 5 minus 8. That's the solution for 4.2.1. And let's go to 4.2.2. Write down the range of f. The range is the set of y values. So you check where your graph is starting. Our graph is starting at this point, going up. Where it goes is going to be positive infinity. We don't know where it ends. So we always focus on the y value, which is the y coordinate, which is minus 8 here. So let me mark minus 8. So we are from minus 8 up to positive infinity. So you can write it as y is an element of minus 8. But minus 8 is part of the solution, or is part of the y values. So I'm going to use the square bracket like this to make sure that I'm including minus 8 up to positive infinity. On the side of infinity, whether it's positive or negative infinity, you always use a round bracket, or you can represent in this notation. You say y is on the upper side, it's going up, so y will be greater than or equal to minus 8. So these are the two ways you can write your range. You choose one of the two. 4.2.3, calculate the values of m and n. M is the x coordinate of this line, so this one you can get in from the axis of symmetry of the graph. So our m is going to be the x coordinate of the turning point, that is going to be minus 5. Now we are looking for m. M will substitute it into our graph of g, because you can see d is lying in graph of g. So that will be y is equal to half. Then our x is going to be minus 5 plus 9 over 2. This gives us 2. So meaning n is the y value, so our n is going to be equal to 2, like this. So m minus 5, n is equal to 2. So let me just write our coordinates of d here, because we might need to use it on the next question. So that's minus 5 and 2. Let's go to the next question. 4.2.4, calculate the area of OCDE. To calculate the area of OCDE, we need to check which shape is this. This one is parallel to this one, because this is a line of symmetry of the parabola. That will be parallel to the y-axis. So if they are parallel like that, and yet there is 90 degrees, this shape is going to form a trapezium shape. Let me just say AOCDE. This is going to be equal to a plus b multiplied by height. Our a plus b, which are these parallel sides. So we need to find the length of ED, length of OC, and the length of EO. But coordinates of E, the x coordinate of E, we know that it's minus 5. The y coordinate obviously is 0 because it's sitting on the x-axis. Then this one is minus 5 and 2. So now we only need to find the coordinates of C. So to coordinates of C, that's the y-intercept of both graphs. So C is going to be at y-intercept, x is 0. Then y is the one which is going to be this value, the constant value of our straight line graph, which is going to be 9 over 2. So now let's see the length of ED. Length of ED, that is going to be, the x values are the same, so they're going to subtract and give us a 0. So that will be 2 minus 0. We get 2. Then the length of EO, that is going to be equal to, our O is 0, 0. Y coordinates are the same, they give you a 0. So how many units are there from E to 0? We have minus 5, so that's going to be 5 units. Distance is always positive. Then let's find OC. 0, 0 gives us a 0, so our length is 9 over 2. So our area, that's going to be half. Our A, I'm going to take it to be ED, which is going to be 2, plus our B, I'm going to take it to be OC, because I said A and B are parallel sides, which is going to be 9 over 2. Then our H is the perpendicular height, which will be this one, EO, which is going to be 5 units. Then we can punch it on the calculator. This is going to give us 65 over 4 square units, or you can express it as a decimal, which is going to be 16,25 square units. So you can leave your answer in fraction form or in decimal form. 4.2.5, determine the equation of g raised to the power minus 1, the inverse of g in the. So to determine the inverse, we have steps that we need to follow. You express your g in the form of y is equal to something. So y is going to be equal to 1 over 2 x plus 9 over 2. So the first thing, you interchange the variables. This one will be x and this one will be y, then plus 9 over 2. Then now we have to make y the subject. So we are going to take 9 over 2 to the left, x minus 9 over 2, that is going to be half y. Then we are going to multiply by 2 throughout. So that will be 2, then 2. I'll just put it in brackets, then I can multiply it once. That will cancel out. Then this is going to be our y. Then 2 times x, we get 2x. 2 times minus 9 over 2, that is going to give us minus 9. So our inverse is y is equal to 2x minus 9. Next question, 4.2.6. If h of x is equal to g inverse of x plus k is a tangent to f, determine coordinates of point of contact between h and f. So meaning this is going to be equal to h of x is equal to our inverse, which is going to be 2x minus 9, then plus k. My equation of f of x is going to be equal to half x plus 5 squared minus 8. Let's distribute the half inside. That is going to be half x squared plus 5x plus 25 over 2, then minus 8. Then our f of x will be equal to half x squared plus 5x. 25 over 2 minus 8, I'm going to get 9 over 2. From h of x, our gradient is equal to 2 because this one is given in the form mx plus c. So our m is 2. So meaning these 2 will be equivalent to our gradient that we get using this f of x. So we need to find the first derivative because we know that the first derivative is the gradient function of any given function, whether it's a parabolic function or a cubic function. Then we drop a 2, that is going to give us x plus 5. 9 over 2 is a constant. Derivative of a constant is 0. Then we equate this one, x plus 5, to our gradient 2. So x plus 5 will be equal to 2. So our x will be equal to 2 minus 5, which is going to be minus 3, like this. Then let's find the value of y. For the y value, we are going to substitute into our original equation, which is this f of x. So that will be y is going to be half x squared, which is minus 3 squared plus 5 multiplied by minus 3, then plus 9 over 2. So this is going to give us minus 6. So our coordinates of point of intersection is going to be minus 3 and minus 6. That's our solution. Question 5. The graph f of x is equal to 3 power negative x is sketched below. A is the y-intercept of f, B is the point of intersection of f, and the line y is equal to 9. So this is our graph. Graph f, then line y is equal to 9 is this one, which is being drawn in dotted lines. Then 5.1 says write down the coordinates of A. Our A is the y-intercept. For us to find y-intercept, we let x is equal to 0. This means our y will be equal to 3 raised to the power negative 0. This will be 3 power 0, which is equal to 1. So our coordinates of A will be 0 and 1, like this. 5.2, determine coordinates of B. B is the point of intersection of the graph of f, and the line y is equal to 9. So at this point, we can see that the y coordinate of B is going to be 9. We don't know the x coordinate. That's the one we need to find. So we substitute with y is equal to 9 into our equation of f, where y is the f of x. So this is going to be 9 is equal to 3 power negative x. Then we express 9 in bases of 3. That is going to be 3 squared is going to be equal to 3 power negative x. Our bases are the same. This is an exponential equation. So if bases are the same, then we equate the exponent. 2 is equal to minus x. Therefore, x will be equal to minus 2. So the coordinates of B is x minus 2 and y 9. Next question, 5.3. Write down the domain of inverse of f. So to make this question easier or simpler, what we need to know is that the inverse of the domain of the inverse will be equal to the range of the original function. Our original function f, it starts here just above this line x is equal to 0, going up. So our range for this graph of f is y greater than 0, like this. Then for domain, you just change the variable. We know that domain is the set of x values, so that is going to be x greater than 0. That's the domain of inverse of f. So our answer, you say x is greater than 0, or some will choose to write it using the bracket notation as x is an element of, we are from 0 up to, was it starts here going to the right, we don't know where it ends, so it's up to positive infinity, like that. 5.4, describe the translation from f to h of x is equal to 27 over 3 raised to the exponent x. So what we need to do, we try by all means to simplify this one into the standard form of an exponential function. This is not the standard form of an exponential. We know the standard form, it should be in the form a b power x plus p plus q. So in this case, we need to take the 3 up. That is going to be 27 multiplied by 3 power negative x, because as you take this 3 power x up, the sign of the exponent is going to change, so it's now negative. Then 27 is 3 power 3 multiplied by 3 power negative x. Then now by laws of exponents, if bases are the same, the exponents will add each other. So this is going to be 3 power minus x plus 3 like this. And after that, you have to factorize the negative sign. This is going to be 3 power negative, open bracket, will be left with x minus 3, because our original function is a negative sign. So after that, you check where from. Let me write our original function here. F of x is going to be equal to 3 power minus, open bracket, x plus what? A 0. This is our original function. So we are from 0, and the new value is now minus 3. So if it's minus like this, it tells us that we have shifted our graph 3 units to the right. If it's minus. If it was positive, that would be 3 units to the left. So our final answer will be the graph is translated 3 units to the right. F is translated 3 units to the right. 5.5. Determine the values of x for which h of x is less than 1. This is our h of x, but we have simplified it to 3 power minus x minus 3. Then it's less than 1. So that is going to be 3 raised to the power minus x plus 3 is less than 1. This is an exponential inequality, so we need to make the bases the same. So our 1 is going to be 3 power 0 like this, because we know any number raised to the power 0 except 0 is equal to 1. Then bases are the same now, so minus x plus 3 is less than 0 like that. Then minus x is less than, we take 3 to the right, that is going to be minus 3, but we have to divide by a negative both sides. But there is a rule in inequalities which says that if you divide by a negative, the sign will change, so that is going to be greater than 3 like that. That's our solution. Question 6. This is financial maths. 6.1. On 31 January, Tsepo made the first of his monthly deposits of 1,000 into a savings account. He continues to make monthly deposits of 1,000 at the end of each month up until 31 January 2032. The interest rate was fixed at 7.5% per annum, compounded monthly. 6.1.1. What will the investment be worth immediately after the last deposit? So he's making his initial deposit on 31 January 2020 up until 31 January 2032. So this is going to help us to determine the time of investment. So he's depositing 1,000 every month. Interest rate is 7.5. So if this is an investment, we are going to use future value, because he's going to make monthly deposits. He's not just depositing money, then he let it grow. He's doing monthly deposits. So this is going to use the future value formula. If it was just, let's suppose he just deposited a lump sum of money, then he let it grow. That's when we use the formula for compound interest, which is A is equal to P, open bracket, 1 plus I raised to the power n. But this one is making monthly deposit, so we use future value annuity. Our formula is going to be F is equal to x open plus I raised to the power n minus 1 close bracket, all over the interest rate. Our x, which is the monthly deposit of 1,000, then 1 plus our interest rate, which is 7.5. we need to convert it to a decimal, that is 0.075, but it is compounded monthly, so meaning this one 7.5 is per annum, so monthly we have to divide by 12 like this. Then n is the time of investment. So let's check how many months are there from 31 January 2020 to 31 January 2032. If we calculate the number of years, we find out there are 12 years plus 1 month. So this is going to give us 12 years in months, that's 12 times 12, which is going to be 144. The 144 plus 1, that's 145. So that's the value of n. Okay, let's just have a clear picture of this one, why we have that plus 1 month. Let's assume we are from 31 January 2020 to 31 January 2021. I just want to make it short to show you why there's an extra month. 31 January, then you go to 31 February, 31 March, 31 April, 31 May, 31 June, 31 July, 31 August, 31 September, 31 October, 31 November, 31 December, then 31 January. Let's check how many months are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can see there's an extra month. That's why we say it plus 1. So let's go back to our question. Then minus 1. Then we close our bracket all over our interest rate, which is 0.075 over 12. We can punch it once in our calculator. This is going to give us 234,888.53. That's the value of the investment. Let's go to 6.1.2. If he makes no further payments but leaves the money in account, how much will be in the account on 31 January 2033? So in this case, he is investing for the further 1 year. He left his money to grow, so he's no longer making monthly deposits. So we can't use the future value formula because now is the lump sum that is growing. So it will follow this compound interest formula. A is equal to P 1 plus I raised to the power n, like that. So that's the formula we are going to use, where P is the principal amount, which is 234,888.53. Then 1 plus our interest rate is still 7.5%, which is 0.075 divided by 12 raised to the power. Is investing it for further 1 year, so that's going to be 12. Now we do not include that extra month because his first month of this investment is by the end of February. This is going to give us 253,123.54 rand. This is the answer for 6.1.2. 6.2, Jim bought a new car for 250,000 rand. The value of the car depreciated at a rate of 22% per annum annually, according to the reducing balance method. After how many years will its book value be? 92,537.64. So we are told that this one was being calculated on a reducing balance method. So the formula for reducing balance method is A is equal to P, open bracket, 1 minus I raised, where A is the book value, then P is the initial or the cost price of the car before it depreciates. So our A, that's 92,537.64. This is going to be our P, which is 250,000. 1 minus our interest rate, which is 22%. So we need to convert it to a decimal. That's 22 over 100, which is 0.22 raised to the power n. Then we are going to divide by 25,000 both sides. And this one, 1 minus 0.22 is going to subtract. That is going to be 0.78. So I'm going to write it on my left. Raise to the power n like this. Then is equal to 92,537.64 divided by 25,000 like this. Then we need to apply the logarithm both sides. That will be log, then by laws of logarithm, the exponent is going to drop. That will be n log 0.78 is equal to log. This one I can keep it like that to avoid rounding off numbers. 92,537.64 or over 250,000. Sorry, I just accidentally wrote 2 and 5. This is 250. Then I'm going to divide by log 0.78. So n is going to be equal to log 92,537.64 over 250,000 or over log 0.78. We can punch it on our calculator. The answer I'm getting is 4 years. It's exactly 4 years. So by the end of 4 years, the car will be at this value of 92,537.64. Next question, 6. Mpho is granted a loan under the following conditions. The interest rate is 11.3% per annum compounded monthly. The period of the loan is 6 years. The monthly repayment on the loan is 1,500. Her first repayment is made 1 month after the loan is granted. Calculate the value of the loan. When you are calculating the value of the loan or the loan repayment, all those things, we are going to use the present value annuity, which is P is equal to X open bracket 1 minus 1 plus I raised to the power negative n all over I. So the monthly repayment is 1,500. So that's our value of X. So 1,500, then 1 minus 1 plus the interest rate is 11.3%. We can convert it to a decimal. That is going to give us 0.113. It's compounded monthly, so we divide by 12. All raised to the power negative. The loan is paid over 6 years. So we check number of months that are in 6 years. That is going to be 6 times 12, which is equal to 72. Then divided by the interest rate, which is 0.113 over 12, like this. And this gives us the value of, we can punch it on our calculators straight. It will give us 78,173.4. Next question, 6.3.2. How much interest will Mpho pay in total over the first 5 years? So in this case, to check the amount that she paid, so what we need to do here, we can calculate the outstanding balance of the loan after 5 years. Then from that outstanding balance, we subtract it from the value of the loan. Then we see how much will be the value of the loan for the first 5 years. So the outstanding balance, I'm going to use, just write it in short, is OB. You know the loan is supposed to be paid over 6 years. So the outstanding balance after 5 years will be left with 12 months to pay, which is 1 year. So that is going to be 1,500. To still use our present value to calculate the outstanding balance, which is 1,500, then 1 minus 1 plus I, which is 0.113 over 12, all raised to the power negative outstanding balance for the last 12 months, then divided by our interest rate 0.113 all over 12. This is going to give us 16,945.01. So now let's see the value of the loan over 5 years. So value of loan over 5 years. This is going to be equal to 78,000, which is the total value of the loan, 173.49 minus 16,945.01. This gives us 61,000 228.48. Then after getting this one, this is the value of the loan over 5 years now. So now I want to see how much was paid over those 5 years. So the amount he paid is 1,500 multiplied by, in 5 years, how many months are there in 5 years? That's 5 times 12, which is going to be 60. This gives us 90,000 rand. That is the amount paid. So now let's see the interest. Interest will be the amount paid minus the value of the loan over 5 years. So that is going to be 90,000 minus 61,228.48. We get 28,771.52.